Okay, thanks for coming this morning. So we're going to talk about, sorry. Does this work? No. Oh. What happens? Yeah, sorry. Okay, maybe some of you know this screen. It's the rt.cpan.org, and it's the way you do a complex search in the rt.cpan.org. And as you can see, it's a quite complex HTML form with a lot of widgets where you can select all the operators for if you want to do an equal, greater than, well, all combinations. So that's one way to build a complex database request. And we're going to talk about another way, which I call the parsed way. And the idea is you have a very simple HTML form, and people type in what they want. They type the operators, the comparison operators. And then it's the job of the application to parse that input to generate the appropriate query. By the way, it's a very old concept. I think in the 70s, IBM had something called a query by example, and it's really that thing here. But it's not so easy to program it just out of the way. So here is a module to help you do that. Before I talk about the module, I will give some background information about another module called SQL Abstract. And then we'll go to SQL Abstract from Query and how to use it. And in the end, some words about the implementation, how it works. Okay, so let's start with a background, SQL Abstract and SQL Abstract More. SQL Abstract is a module that takes as input Perl data structure, and as output, it produces the SQL. Maybe many of you are using that module. Maybe you don't know it because it's one of the internal components of DBIX class, the ORM framework. But it's not only used by DBIX class, it's also used by some other ORM frameworks like DBIX data model, and it can be also used on its own. So let's say a few things about how it works. You call the select method, say in which table you want to query, which columns, and this is the important part, the green part, where you have a hash ref which specifies all the conditions, the criteria for your query. And as you can see, the values here can be several things. They can be just a straight scalar value, or it can be a hash ref with an in operator. Here is an example of between operator. Here's an example of comparison operator, and so on. And from this, SQL Abstract generates the code which is on the bottom of the slide. Now, why is that interesting? Because, oh, I'm sorry, my computer doesn't want to advance. Yeah. Why is that interesting? Because programmers no longer have to play with string joins and splits and so on. And it prevents you from SQL injection because the module takes care of the placeholders and bind values. Okay, SQL Abstract also has a special operator. That's a way to extend the syntax it understands. So if you need, I showed you before the examples of in operator, between operator. If you need something else, like a full text operator, you can extend it to the syntax that SQL Abstract understands. And that's useful when you want an abstraction that will, for example, get away from the details, how you do full text in Oracle or how you do full text in MySQL. You build an operator like here, and it will, and then you define the different implementations for your various database vendors. Okay, SQL Abstract More is a subclass of that. which adds a couple of things. It adds named parameters. So instead of positional parameters where you have to give the exact number of parameters, you can here have named ways to associate the values. And there are a couple of extensions like support for unions, intersections, and so on. So these are both nice modules for programmers. Now we get back to the original question: what happens for the users? And this is what the module SQL Abstract from Query works about. So again, this is the slide I had at the beginning, and the job of our module is to detect what the user wants here. Probably if there is a star, the user wants a like operator. Probably if there is a comparison operator, the user wants a comparison. So we have to parse all of that stuff. And the result should be something like that. The result should automatically add this operator like, add this not in operator, add this thing here. And once we are there, we can go to the final SQL through SQL Abstract. So here is the way to use it. You declare a parser, or you create an object which is a parser from that module, SQL Abstract from Query. And then you just call the parse method. The argument to the parse method is HTTP query. What we mean by that, it has to be an object with a method called param. And this is kind of standard way for every web framework. I mean, the plain old CGI has a param method. The plaque request object has a param method. The catalyst and so on. So any of those will fit here. And you can also pass just a plain href. It also works. So this input is supposed to be what the user has typed. And the output that you get, I called it criteria here, is a href that you can feed directly to SQL Abstract. So then you call here criteria, and SQL Abstract will do its work. Or if you are using SQL Abstract more, same thing here, you put the criteria href here. So this is the way you use it. Now it has a couple of options when you instantiate the object. One option is to add some additional components, more or less like Moose roles. And one option is to specialize some fields of your HTML form, because sometimes you don't want a field to accept the whole syntax. You want a field to be specialized to do some, let's say, a date or a Boolean or whatever. So we are going to see these two options. First, components. Components are extensions of the basic behavior. They inherit from the base class in two ways. Both in the classical object-oriented way, they can override some methods, and also they can override the grammar. They can override some rules in the grammar. So you can extend the grammar that your module understands. Within the distribution, I have three such components which are already there. One is FR to give some support for the French language. So instead of, for example, for the Boolean values, instead of true, false, it will understand vrai, faux. One other extension is Oracle. This component will automatically insert the proper SQL to do with Oracle date. You know, in Oracle, it's a pain. You have to convert. There is a toDate function in the SQL that you have to do the conversions. And this component will do that work. And there is a third component, contains, which gives some support for full text queries. And of course, you can write other components to give a richer behavior for your parser. The other extension is fields. So when you instantiate the parser, as I said before, you can say this and this and this field in my HTML form, I want them to be associated with one specific rule of the grammar. So instead of the standard rule accepts almost everything. It can accept a string, a Boolean, a date, an operation on those, But if you want to restrict it, you have this field option when you instantiate the parser. Okay, that's how you use all of that. Now we're going to talk a little bit about how it is implemented. The secret to all of this is a wonderful module by Dami Conway called Regexp Grammars. Probably some of you know that. It was presented, I think, in YAPC Vienna a couple of years ago. And it's really a gigantic hack, but it's a hack that works very well. It takes as input a grammar, and it will translate that into Perl regex. So then it's the Regexp engine from the Perl interpreter that parses your input. I won't present that in detail because it would take a very long time, but here is an excerpt from the grammar I'm using in the module. You can see we define rules. A rule can call other rules, or a rule can call a regular expression. And this is the way to... it's really like the parse rec descent module also from Dami Conway, which was the ancestor to that one. So it's a recursive descent parser. It goes down, it tries to parse, and it brings back the values, and what you get at the end is a data structure that you can use in your module. And for each of those rules, when it fires, it has to return some value. The way to do that, it can be done either in the grammar, or it can be done in what is called autoactions. So these are Perl methods. They have exactly the same name as the grammar rule, and automatically it will call that method to decide what should be the return value. So in the example here, remember in the grammar I had a rule for between construct. So it will automatically call this method here, and this method returns the appropriate data structure that SQL abstract wants for generating the SQL. So it's very simple to understand and very simple to extend if you need to extend that. Now, what is really great about Regexp grammars, and that's really the only parsing engine that I know of that does that, is it can do inheritance. So you can take one grammar and inherit from it, and either you add some new rules into the grammar, or you can override rules from the parent grammar. So this is exactly what was used to implement when I said before, the FR component, the one that gives me some support for the French syntax. We define a new grammar. It extends the base grammar. It overrides the null rule, because now we are going to accept null with only one L in French, or with two L's in English. And here it overrides the between rule, some support for the French language, but it also calls the parent rule from the parent grammar, so it supports both English and French. So as you can see, it's a very powerful way to do some parsing in a modular way. I really like that about Regexp grammars. Of course, we can do regular inheritance in the usual Perl object-oriented way. So here is one example where we override. This example is from the Oracle component, where we override the date method to insert what I said before, is insert some special syntax for Oracle. And again, this overridden method can call the parent. Here we are using a way to call the parent, which is called, it comes from this module, Emero C3, because we want to be, it's a way to make sure that when we do multiple inheritance, we go through the proper sequence of parent classes to find the parent method. And I think that's all about the implementation that I wanted to say. So in conclusion, we have a module that can accept very flexible syntax from user input. It has some basic support for internationalization, but the only component that comes with the distribution is French. Of course, if somebody wants to give me some modules for other languages, that would be great. Or you can publish that as separate CPAN distributions. And we have support for specific behavior in some fields. And last thing is tomorrow, thank you. Well, actually, I was faster, so I'm almost finished. But tomorrow, I have a longer presentation on an application called App AutoCRUD, which relies on that module to do all the searching. So if you want to see more details, please come tomorrow. So I have time for questions. That's the end of the presentation. Thank you.
Does anybody want to ask something?
What happens when the user passes an unknown parameter to the form?
If something is rejected by the grammar, you get an exception. So then your application has it's a structured exception. So then your application has to decide what to do with that. You have to display something to the user to say your input was not valid. No, the module knows nothing about the database. The module, all it knows is it generates a data structure that then you put that data structure in your ORM or directly to DBI, whatever. So the application, for error handling, the application has to do two things. First, it has to check that the parsing went okay. And if the parsing went okay, then you go to the database, generate the query, and then you have to check that that query also went okay. But the module knows nothing about the database.
So if an unknown parameter is passed, you will have an exception on when you do the query.
Yeah, in that case, it's the database that will return an exception.
What type of information do you give in the structured exceptions?
This I don't really remember. I think it's a hashref with the field names. So for each field you have an error message, and the error message. Well, it's a long time I haven't. I think it comes from Regexp grammar, the exception from Regexp grammar.
Not suitable for users, then.
No, you have to adapt it a little bit. Yeah.
Any more questions?
Have you tried using MO and PO files for internationalization?
I don't understand.
MO and PO files. It's files that have information about internationalization for different languages.
The question is, have you used getText for internationalization?
No, I haven't. Actually, I didn't know about that, but I think there was a presentation here at YAPC on
yesterday.
that topic. Yeah, I was. So I discovered that that module.
All right. Any more questions? Let's thank our speaker.
Thank you.